So I'm going to start by talking about actually where we are today and what this technology actually enables versus not. So earlier today, I was in a meeting with a bunch of Dell executives, and one of them asked, is this thing really intelligent? Like, how can something that's just math be intelligent? And I answered, actually, yes, it is intelligent in a fundamentally different way than before. And the reason is, if you think about humans and these models, they're both learning systems. So we get data, and then we kind of update ourselves, and we build a better model of the world, and we build a better model of each other as we get more data about the world. The same thing is happening with these models. They're getting data, and they're building a better model of the world, and they're building a better model of humans as they see more data. And the thing that has changed, there's two things. One, the architecture, and two, the amount of data. So because these models are optimized for trying to predict data, the data that it's seeing on the internet, it actually turns out that the best way to predict the next word when reading the internet is to develop a better underlying model of the things that are generating what's on the internet, which is humans and the world. Because on the internet, we're talking about ourselves, we're talking about each other, our relationships, and about our interactions with the world. This is why these models are able to learn true understanding of the world and why they can pass the Turing test. And so they do have an understanding of the world in the way that we understand the world. And the transformer architecture, which actually is not new, it's not in the last 6 months, it was invented in 2018, 19. The transformer architecture is fundamentally different in the sense that it's actually a lot more general. So previous architectures that we had, even if you fed it all of the data of the internet, it would not be helpful. It would forget the older things that you fed it. It wouldn't continue to develop a better and better model. This architecture lets the model develop a better and better model of the world. So it is fundamentally different. However, and this is, we train foundation models optimized for reasoning. I train models day in and day out. And this is where the limitations come in. These models are very good at modeling the text on the internet. But on the internet, there are things we don't talk about. For example, we don't go into the nitty-gritty of how we plan an offsite. We don't talk about the fact that goals might change. So as an example, my EA was planning an offsite for our team to go rock climbing. She finds a date. A week later, a person on the team is like, I can't make that date anymore. She's like, okay, well, find a new date. Then the next week, another team member says, I can't make that date anymore. And so she's like, okay, guys, we need to change the goal of what we're trying to do here, and we have to let go of this constraint that everyone has to be able to make the offsite. So if I think about what my EA was able to do in this situation, she challenged the current stated goal, and she said, no, we have to change the goal. ChatGPT, current AI systems, they can't do that today. It's not because they're fundamentally limited in what they're able to do. It's because when you're training on the internet, there's just not good data on the internet for this kind of situation. It's not optimized for this. And so, as a result, in order to build agents that are actually useful, I believe, we have to actually train the model using data that is optimized for reasoning. This is kind of a dealing with goals changing, telling you things are impossible, trying to figure out what the situation is. I call this all class of problems under reasoning. And so we build reasoning agents that are optimized for reasoning and code. And I think if you think about what we can reasonably expect to come in the next year or 2 or 3, what I just described with my EA, I think this kind of thing is going to start to be possible in the next year or maybe 2. And this is not very far off. This is, what we'd call quintessentially human capability, this ability to see what's going on, what the constraints are, what the goals are, and change them and push on them and try to actually get things done in the world. And then in terms of the kind of very interesting stuff that's coming later in the 2020s, so we work on agents that can code, that can write software independently. And you instruct them in natural language, and they can write a new interface for you. And they can modify your software code base and come back to you and tell you something's impossible or tell you how to change the way that you're implementing something. When you have software that can write software, like you have computers that can code themselves, all of a sudden computers start to look very different. Right now, as Tim said, we need to know how to code in order to tell a computer what to do. But there is a future in which we can just talk to a computer and tell it what to do, and it will change itself based on what we tell it. Of course, we have to understand, a bit more of the nitty-gritty of how it works, but this is a very powerful change in the medium of what a computer is. And so I'm going to leave you with that.
Thank you. Fantastic.